In this video, we will prove a theorem using the principle of mathematical induction. Example 2.26. Finding the sum of n consecutive odd integers. So what is the sum of n consecutive odd integers? Well, there is a theorem for this. It's equal to n squared. We shall prove this using mathematical induction. So again, this is the organization of your proof. To prove a theorem by mathematical induction, you will of course state the theorem. And then you will begin the proof. And your proof has three parts. You have the base case. You will write the inductive hypothesis, and then you will show that P of k implies the statement is also true for the next integer. And if you have shown that, you will make now the conclusion. We begin by stating the theorem that we are supposed to prove. Let n be a positive integer. This is the theorem, and this is how we write it. This is the general term for an odd integer. This is how you write an odd integer. So we begin the proof by writing the word proof, and again, this is the organization of our proof. The first part would be the base case. That is, you must show that the theorem or the proposition is true when n is equal to 1. Is the proposition true when n is equal to 1? Well, yes. 1 is equal to 1 squared. How about when n is equal to 2? 1 plus 3 is 4. 4 is 2 squared. It's true. How about when n is equal to 3? That would be 1 plus 3 plus 5 is equal to 9. But 9 is 3 squared. So the proposition is true for n is equal to 1, to 2, and to 3. Again, if we were to go back to the principle of math induction, it is not necessary to show that the proposition is true when n is 2 and 3. In fact, all you have to do is show that the proposition is true when n is equal to 1. When I was a student, I was doing this for myself. I just want to be convinced that the proposition is true. Am I just to accept that the proposition is true? Or maybe I have to investigate it myself. And showing that the proposition is true for n is equal to 1, to 2, to 3, it kind of convinces me that, hey, this proposition is true. And not only that, I am seeing the structure of the proof. I am also seeing the structure of the theorem. We now go to the inductive hypothesis. This is where you will make a temporary assumption. Suppose that for a natural number k, this statement is true for k. That is, the sum of k consecutive odd integers is indeed equal to k squared. Okay, so we are already here. So we will now show that this is also true for the next integer. And that next integer is k plus 1. Using the inductive hypothesis, the sum of k plus 1 consecutive odd integers is... Okay, so we will write it formally using your sigma notation. It's equal to this. Now, don't be easily overwhelmed by the equation. Okay, so we will show it one by one. So this one is the sum of the first k consecutive odd integers. And then what we shall do is we shall add the next odd integers after the last odd integer. So this one is equal to 1 plus 3 plus 5 plus so on and so forth until we get to 2 times k minus 1. This is the kth odd integer. We will now add the next odd integer. That next odd integer is this. If you were to simplify that, that is 2k plus 1. In fact, if you want to obtain the next integer, the next positive odd integer after 2k minus 1, all you have to do is to add 2. And when you add 2 here, minus 1 plus 2 is 1. That's why it becomes 2k plus 1. Where did this come from? It comes from your inductive hypothesis. This is equal to k squared. That's why using the inductive hypothesis, all right, this part is equal to k squared. Your inductive hypothesis supports you there. It supports this part of the statement. And then 2k plus 1, you are just adding the next odd integer. And you know what? This is actually the square of a binomial. It is equal to the square of k plus 1. And so that's it. We have shown that the proposition is also true for the next integer after k. And the next integer after k is k plus 1. Look at this. The summation of the k plus 1 consecutive odd integer is equal to the square of k plus 1. And so, by the principle of mathematical induction, you are now prepared to make the conclusion. You are now at the third part, the last part, make the conclusion. Using the principle of mathematical induction, the sum of n consecutive odd integers is n squared.